Hello everyone, I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we'll study about atomic structure. Before we study semiconductor material or PN junction diode, it is very important to understand the atom and its structure. All matter comprise of the fundamental particles known as atom. Central core of the atom, it is known as a nucleus. Nucleus contain protons and protons are positively charged, as well as nucleus contain neutrons. Neutrons do not have any charge, and that is why nucleus is positively charged. Around the nucleus, we have different orbits. All the orbits are elliptical in shape, and electrons rotate in different orbits. Electrons are negatively charged. We have number of electrons in any matter, and all the electrons rotate in different orbits. Maximum numbers of electrons in any orbit, it is given by one mathematical equation, that is 2 multiplied by n raised to power 2, where n is number of orbit. N can be 1, 2 or 3 or more. We have different permeable level 1, 2, 3, and electrons cannot rotate in between any permeable level. Suppose we consider n is equal to 1, that is our first orbit. So 2 multiplied by 1 raised to power 2, and that is equal to 2. The meaning is, in the first orbit we have maximum number of electrons at 2. If we consider n is equal to 2, second orbit, then maximum number of electrons in second number of orbit, that is 2 multiplied by 2 raised to power 2, that is 8. For example, if we consider third orbit, that is n is equal to 3, then maximum number of electrons in the third orbit, that is 18. So on, we have number of maximum electrons in different orbits. But the outermost orbit cannot accommodate more than 8 electrons, and that is known as a valence electrons. In semiconductor material or PN junction diode, we are interested in these valence electrons. We have different energy levels. The level of energy of electron depends upon its orbit, whether electrons are in first, second or third orbit. Accordingly, the electrons possess the energy. The total energy of an electron closer to nucleus is minimum, and that is why to remove the electron from its orbit we need more energy to be imparted, the energy level in the next cells are higher. The energy is expressed in electron volt and it can be indicated with EV, that is electron volt. And 1 electron volt is equal to 1.602 multiplied by 10 raised to minus 19 joules. So this is energy possessed by electrons. When energy is imparted in the form of light, heat or radiation to electrons, and if energy is sufficient, electron comes out of its orbit and shift to the next level, that is outer orbit. But if electrons comes to the inner level from outer level, it radiates the energy. So to detach the electrons from its orbit and to take it to the next level, we need to impart the energy. On the contrary, if electrons are coming to the inner level, it radiates the energy. Now let us study energy bands. In an isolated atom, so far we have about energy level, that is correct. But we have number of electrons in each orbit and all the electrons possess slightly different energy. So instead of indicating the level of energy, now we have to identify the energy band. The range of energies possessed by electrons of the same orbit is known as the energy band. Now let us see how we can describe the energy bands. We have level of energy. In the first orbit, we have billions of electrons, and in first orbit, electrons possess slightly different energies, and that is indicated with the first band. Same way, we have second band. As we discussed earlier, the energy possessed by the electrons closer to the nucleus, that is first band, that is minimum. As we go on outer cells or outer bands, the level of energy in electrons increase. So width of the band goes on increasing as we go on outer number of bands. Same way, we have valence band, and at last we have conduction band. The electrons in the valence band are having maximum energy, and that is why to detach the electrons from the valence band we require least energy. Mostly the electrons in valence band are loosely connected with the nucleus, and if we impart certain energy in form of light, heat or radiation to the electrons of the valence band, then it is possible to shift electrons from the valence band to conduction band. Valence band mostly are fully filled with electrons or partially filled, but it is never empty. Same way, conduction band, either it is partially filled with electrons or it may be empty. So when we impart certain energy, and if level of energy increase in the electrons of the valence band, then it shift to the conduction band. In the conduction band, we have number of free electrons and current passing through the solid material. That is because of these free electrons in the conduction band. The energy gap between valence band and conduction band is known as the forbidden energy gap. We have discussed that electrons in valence band are having maximum energy, but to travel or to shift electrons from valence band to conduction band, it requires certain additional energy, and the energy required, that is equal to the width of this forbidden energy. The width of the forbidden energy indicates the bonding of valence band electrons with nucleus. So when we impart energy equal to the forbidden energy, then electrons can shift from valence band to conduction band. So thank you for watching my video. Keep watching. Thank you very much.